Hi and welcome to today's video. Today we're going to talk about simplifying square roots. Hopefully this is a review for you. This is something that you did in Algebra 1, so it should be fairly familiar, but we're going to just kind of review some things because when we get on to imaginary numbers a little later on, these are going to be very helpful. So first, a little vocabulary. A square root is just a number that, when multiplied by itself, produces another number or quantity. So a radical sign, this is what a radical sign looks like. It's a simple symbol that we use for taking a square root. The radicand is just simply the number underneath the radical sign. And so note, if a square root is an integer, or of an integer is not an integer, it is an irrational number. So for example, the square root of 4 is 2. Since 2 is an integer, that's obviously not an irrational number. But the square root of 3 is, there is no even number that you can take the square root of 3. So the square root of 3 is irrational. So I have another example of that here, the square root of 75. If we notice that if we look at 8 squared is 64, and 9 squared is 81. So 75 is somewhere between 64 and 81. So the square root of 75 is somewhere between 8 and 9. We can use a calculator to actually calculate that a little more somewhat precisely. And we find that the square root of 75 is approximately equal to 8.66025. And it continues on. So the square root of 75 is also an irrational number. We'll take a look at how to simplify that square root here in just a minute. So first of all, some square roots for some rules for radicals. First of all, the square root of a times b is equal to the square root of, well, a times b, which is equal to the square root of a times the square root of b. So in other words, if we have two radicals, we can combine them into one. If we have one radical and we want to split them up into two, we can do that also. So here is an example of that. The square root of 12, that's the same as the square root of 4 times 3, and that is also the same as the square root of 4 times the square root of 3. And notice here we could take the square root of 4 and find out what that is. Okay, in the second rule, so any two radicals can be multiplied together, is what this is saying. In the second one, the radicands must be the same in order to add or subtract. But if they are the same, we can't add them or subtract them, just like if they were variables. So for example, x times the square root of a plus y times the square root of a is equal to x plus y square root of a. So an example with maybe some better numbers, 3 square root of x plus 4 square root of x is equal to 3 plus 4 times the square root of x, or 7 root x. So they work just like variables. If this were just x without the radical, and same with this one, 3x plus 4x is 7x. So they work very similar when we're adding or subtracting. They work very similar to just using variables. Okay. The third rule is the square root of a squared is equal to the square root of a quantity squared, which is just equal to a. So you might realize, for example, the square root of 9 is, well, 9 is 3 squared, 3 times 3. So when we take the square root of 3 times 3, we just get 3. So basically what this is telling you is if we have a squared inside here, these end up canceling each other out. So the square root of 3 squared is just 3. Okay? So if we had the square root of xy squared, that would be the same as the square root of xy quantity squared, which is just equal to xy. Be careful here, however. One thing that you should note, the square root of 9 plus x squared is not just 3 plus x. We cannot take the square root of 9 and the square root of x squared and get 3 plus x. It violates the order of operations to do that. So be very careful when you're doing that. Okay, so simplifying square roots examples. In our very first one, we're taking the square root of 225. Well, the nice thing about 225 is that is 15 squared. So the square root of 15 squared is just 15. Sometimes it's helpful to use a calculator and see if it works out to be a nice even number, or maybe you'll recognize it to be a nice easy number to take the square root of. For example, 16, you probably know is 4 times 4 already. So if you had a problem that said the square root of 16, you wouldn't need to get out a calculator to do that. Hopefully you would just recognize that as 4. Example 2, here's our first method of now simplifying a radical. Notice there's a difference between simplifying and simply calculating. Okay, so here we could find a decimal approximation for this, but when we're simplifying, we want the exact value. So what we're going to do is we're going to split that out. We're going to take out the perfect square, which in this case is 4. So we're going to just divide it up. So we have the square root of 4 times the square root of 5. Notice 4 times 5 is still 20. So when we take the square root of 4, that is 2. So our simplified version of this is 2 times the square root of 5. Okay, 75. 75 is the same as 25 times 3. If you have 3 quarters, you have 75 cents. So 25 times 3 is 75. You might recognize the square root of 25 is a perfect square. So the square root of 25 is just 5. So this becomes 5 times the square root of 3. And like I said, this is not the same as calculating the square root. We're simplifying. And so each of these problems, if you put a decimal approximation by each one, that's not what we're looking for. That's wrong. You need to simplify them just like is shown here. The second method you might use for maybe some more complicated problems, like for example the square root of 448. I don't know what perfect square, just looking at this, that we could take out. So it might be easier to make a factor tree. So do a prime factorization. So I did notice that we can take 448 and divide it by 4. So I split that out. 4 times 112 is 448. And I know 4 is 2 times 2. That one's easy. 112, well, I know 2, I can divide this by 2 still because it ends in a 2. So 112 divided by 2 is 56. So 2 times 56 is 112. And 56 I happen to know is 8 times 7. So I can split that out into 8 times 7, and 8 we can further factor into 2 times 2 times 2. So what we have for our prime factorization is 2 times 2 times 2 times 2 times 2 times 2, or 6 times altogether, times 7. So now what we do is we pull out all of the pairs of factors. And by pairs of factors, I mean numbers that are the same. So we have a pair of 2's here. When we pull out that pair of 2's, this is like 2 squared. So when we pull it out, it becomes just 2 on the outside. Same with this pair of 2's. When we pull it out of the radical, it becomes just another 2. And same with this pair of 2's, it becomes a third 2 on the outside of the radical. So when we take out all of those pairs, the only thing left over underneath the radical is the 7. So we have 2 times 2 times 2 times the square root of 7. And so we can just simplify 2 times 2 times 2 is 8. So our final answer here is 8 square root 7. Our final 3 examples. First one, multiply and simplify. So to multiply and simplify, what we're going to do is just like it says. We're going to multiply them all together and simplify. Sometimes it's easier, though, if we just kind of leave them kind of factored out a little bit. So 7 I just bring down, and notice 54 is 6 times 9. So I happen to see that 9 is a perfect square. 6 and 7 don't have anything. If we were to multiply those together, we get 42, and there's really nothing that we can, no perfect squares we can take out of 42. But be careful here. If there was a common multiple here, or common divisor here that we could take out, we might be able to simplify it more. But in this case, 9 is the only thing that we can take the square root of. So take the square root of 9, that's 3, leaving us with square root of 7 times square root of 6, which I mentioned is the square root of 42. So altogether, simplifying this, we get 3 square root 42. Okay, next one is distribute and simplify. So when we distribute and simplify, we have 6 times root 10 plus 4. So we're going to distribute 6. Square root of 6 times the square root of 10, we get the square root of 60. Square root of 6 times 4 is square root of 6 times 4. So notice the square root of 60 now, we can simplify that a little bit more. 60 is 4 times 15. So we can split 60 up into 4 times 15, but we really can't do anything with this. It's as simplified as it'll go. But here, when we take the square root of 4, we get 2. So 2 root 15 plus 4 root 6. And that's all we can do with that one. And then the last one, simplifying with addition or subtraction. So you'll see some problems like this when we simplify them or combine like terms. We will have some that are alike and some that maybe are not alike. So in this one, negative 4 root 3 minus 2 root 3 minus 4 square root 80. The 80 we can simplify some. So let's do a factor tree on that. 80 is 8 times 10. 8, well, let's take a look. 10 is 2 times 5. And sometimes you don't have to necessarily do a complete factor tree. Here I notice that 8 times 2 is 16, and 16 is a perfect square. So I'm going to make 80 into 16 times 5. But the factor tree did help me to find that. So here, since these are like radicals, we can combine these. So negative 4 root 3 minus 2 root 3 is negative 6 root 3. And notice I kept it the same all the way down. 4 root 80, notice I did split it up into the square root of 16 times 5. The square root of 16 is 4, so it comes out. And on the outside, 4 times 4 is 16, root 5. So we end up with negative 6 root 3 minus 16 root 5. So that's it for today. Hopefully that was a good review, and I hope to see you again next time.